Good morning, everybody. This is the last class in this semester. And I hope all of you doing fine. So we are going to have the presentation today. And again, I like to have all of the PhD students to present first, okay? All right, just a second, let me get my name list. Okay,
Professor, I think I'm first.
excuse me?
I'm the first, right?
Oh yeah, you're the first. Okay, I'm just checking how many students are already in the class.
All right.
Okay, and it seems that Moody is not here yet. And we still have two master students is not in yet. Okay, well, I think we need to really save our time. And I think we just started from Gloria, okay, to do the presentation.
Okay.
Okay.
Okay. Let me show my documents, my page.
Okay.
Can everybody see there?
Yeah. Would you please make it a little bit larger?
Okay, sure. Is it okay now?
Okay, sure.
Okay. That's my work at the class activity 6. So the first question was that to download data file TB from the class iLearning system, which I have done. So they said they put TB6 and TB3 series individually in the same diagrams, and it is look like this. Yeah,
All
almost
right.
very similar. So they are. It seems to me as not stationary to me. But when I taste each series of stationery with the uni route, including the intercept and the trend with various lectures, that's what I got. And when I taste the TB3 with the 4 leg, we can see here the probability is 0.04. So it's significant. So and when I use the 12 is much smaller. So also it is significant. And when I use the leg 2, it is like this. So it seems to me that if you are use different legs have different meaning. So I test TB6. I use 1, 4, and 12. So they are all stationary. When and question 3 to test if two series are co-integrated. So I used time as another x variable and get its residual and apply Dickey flow test to check if they are stationary. That's what I got in the e-views. So I make model A and it is stationary. So in the question C is a model A series regression. Since p-value is less than 1%, so I think it is spurious, yes. So the question D said, does the long run equilibrium is in the model A? Because model A is stationary. So the TB6 and TBA are co-integrated. So we can say that there is.
Excuse me. Okay.
Yeah.
Gloria.
Yeah.
The
All right.
So this is test for residual, right?
Uh-huh.
Okay. So it means that, what does that mean?
So it is to me.
So model A
Mm-hmm.
means the one with time time and time two
Yes.
uh, is what?
Time title they are not that significant.
So we are asking that unit is model A spurious regression,
Uh-huh.
and
I think it is spirit, no? Because they are small.
well, in in these questions, okay, in
Uh-huh.
this question we were asking that
Mm.
they are whether these two series are co-integrated.
Mm-hmm. They are
So based
uh,
on the test,
right.
which is the
Going.
residual is stationary, right?
Yeah, they are stationary.
So they're co-integrated.
Yes.
They are co-integrated, and if we say they are co-integrated, and is model A spurious?
Oh. Ah, okay. It is not.
Yeah,
Because
it is not
it is
spurious,
not
right?
spirit. Yeah, it is not.
Although based on the original
Yes.
TB3 and TB6,
Uh-huh.
it seems to be spurious.
Yes.
But
Yes.
after we
But
test,
they are
uh,
co-integrated,
yeah,
so they're not spirits.
they are
Yes.
not spurious. Okay,
Okay, okay. Thank you.
okay.
Thank you
Then
so much. I will change
go
that.
on, go on.
And then okay. So they are integrated. So I run the long run relationship. So that's what I
Mm.
got. For the answer, I run the ECM for TB6 and TB3.
No, excuse me. Number four,
Yes,
the
number four.
D part. Does
Uh-huh.
the long run equilibrium exist in model A?
Does D part?
Yeah, D part.
Oh yeah. So my question is, there is long runs in preceding Piro Model 8 because they are. So I think they are integrated. That's why I say maybe they are have long run.
So that, and what is the long run equilibrium?
The
You
long
know,
run equivalent.
for this question, does the long run equilibrium exist in model A? Then I think the answer is just not yes or no, right?
Right. So I maybe I makes
Any
understand.
any yeah, on what kind of information from model A?
Model A is not spurious.
Yes. So any information from model A?
Model A. To me, they are the probability they are very significant. So
So we do have long run equilibrium relationship exist.
Right.
in this model, right? And there's a long run coefficient, right?
Right.
Equilibrium coefficient. And what is it? Okay, okay. Continue. Okay. We'll explain this one later on.
Okay, thank you.
Okay.
So,
So number,
yeah,
yeah.
4. So that's what I got in the number 4 as
Mm-hmm.
long run the ECM. So that's my results.
Okay.
And for the B, coefficient are individually statistical at the 7 level or lower level. And this my number as a
Uh,
C.
okay. Excuse me. Run. Okay.
Yeah.
B. Explain the meaning of the coefficient of ECM. So
The,
this is the number 4, B parts. Explain the meaning of the coefficients of ECM.
yeah, I think the coefficient. Wait a minute. So I think coefficient is significant at the 7 level because what the, coefficient is 7 level. Hmm. Professor, I think I cannot explain now.
Okay. Never mind. We'll wait until other students. Okay. Then how about how about C? What's the C? Explain the process from.
Coefficient shows at 1 is at increase. Coefficient C. That's
Yeah.
what I got. When I done it, I forgot it. Okay, the coefficient shows at 1. Hmm? Eh? Oh, okay. So that's what I from the this uh in e-views. So if you 1% less in TB3, so that will cause the TB6 at 80%, 0.88% increase in TB6.
Mm-hmm.
So it is the short run elasticity, what I done
Mm-hmm.
here. The long run value is given co-integrated regression about 97%, which shows here.
Mm-hmm.
So the coefficient of the arrow direction turn is about 0.2.
Well, this is not model A. This is
Uh-huh.
just use only times. We need
Mm.
to time square too.
Oh, so I made a mistake. Okay.
Okay, you
I have to
already done
use time
the
too?
one
Uh-huh.
the model model A is the one we required.
Ah, all right. So I
You have
made.
already done it. You already have done it for model A, right?
Mm-hmm. Right.
Which
So
is on
previous. Yeah.
the third part A, part A.
Uh-huh. Yeah. Yeah.
Yeah, this is what.
Mm-hmm. Ah, okay.
No, 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 no,
Oh,
no, no. This is not the one. Model A. Where's your model A?
from all the way. This not?
Oh, excuse me. This dependent variable should be TB6. And
Yes.
independent variable should be TB3.
So I do the verse.
Look at your A model. Upper one. Question number 3. This one, did you see that? Did you see that? Okay, here.
Yeah.
Did you see that using dependent variable is TB3? It should be TB6.
Should be TV6. All right.
And TB3 is independent variable.
Okay, I will correct it immediately.
Okay.
Yeah, thank you very much.
Okay, continue.
Okay, what I
So what you explain it on the number 4, C parts, is also wrong because it should be based on the model A.
yeah, C part.
And model A is with TB6 as the dependent variable, and TB3 and time 2 are independent variables to run the model. This is what we call our ECM of model A.
Okay, thank you. Okay, so this is wrong.
Okay, so okay, then so explain the last parts of Granger causality test.
So I do the Granger causalities of TB6 and TB3. So this is what I done.
Okay, what do you have?
So the probability of the individual are, to me, TB6, they have the Granger test course with TB3. Because you see, and I do this, and then I do the test. So it is so small, so they have a range of cost from TB6 to TB3. So, and I do another one. They are not significant. So as you can see here, so I think TB3 does not Granger cost with TB6. So they are not not liberal relationship.
Okay. All right.
Okay, thank you.
Okay. All right. Thank you.
Thank you.
Now it's Andy.
Yes, bro.
Andy, will you show your
Yeah.
work?
Yeah.
Are you okay in Indonesia?
Yes. It's ready, bro. See my work? Hello?
Yes,
Hello?
can be seen.
Yeah.
Yes, we see it.
Okay.
Yes. Yeah. Okay. Okay.
Good morning, Professor and my classmate. Yeah, I'll try to explain my assessment 6 Before that, I'm running for individual variable, TB3.
Oh, okay.
This one,
Okay, sure.
yeah, this
Sure,
one,
sure.
yeah, this one, the plot look like, and then TB6. We see this one looks similar, but when we running join the variable, we see same, that one. And then for number 2, they use unitrot including intercept and train with various lactam. What do you find the result? For variable TB3, we see this one, the variable for the critical value is significant, it means stationary. Because why? We see this one, the statistic 4.134755 and probability 0.00. And then 1%, 3.98531, and then 5%, 3423136, and 10%, 3.134497. But this one, I'm more confusing for because we same with gonorrhea, but why the result different? And then this is the explanation. Based on the research unit trust test, the variable TB3 is stationary because this statistic higher than critical value, 1%, 5%, and 10%, and probability lower than critical 0.1%, 5%, and 10%. And then we're running with variable TB6. So we see only for variable, only critical value stationary with the 10% level because this statistic of TB6 3.165412, and then the other one higher than this statistic only 10%, 3.134315, and then probability higher than 5%, but for 10% is stationary. This is the explanation, the summary. Where I make summary, I make this one only 10%. And then for number 3, regress TB6 on TB3, time and time 2, call it model A. And then we're running this one. All of them, variable is the significant because the probability 100 0.05, and then statistic higher than 1.97 by T table. This is the explanation about that. And then for B, use unirod including non-excess with various task term. And then we're running that one. We see only critical value 5% and 10%, 1% not. Because why? They more lower than 1%. We got this one for TB6 with uniroot and excess noun 2.553164 and probability 0.01. Only one level cannot be stationary. It means not significant because higher than t-statistic. This is the explanation about the result. Is model A severe segregation? I said yes. Because why? This one we see this one. Model A. Because the coefficient is minus, it means if increase 1% of the time will be decreased 0.002 of the variable TB6. This one, bro. And then for D, does the long run equivalent exist in model A? I said yes. There is a significant effect between independent variable to dependent variable. Then the coefficient variable TB3 is 0.95841. The statistic 151.94 or not higher than T table 1.7 97 probability lower than 0.05 is mean long run or equilibrium. Also, with the answer number B, we can see this is only for my opinion, Prof. I don't know this is correct or not correct. Also, we can see the answer number C, number B, the result of unit explain probability residual 0.01 and statistic residual minus negative 2.553164 has significant effect on critical value 5%, negative 1941740 and 10%, 1.61687. I can say they have long run stationary. For number 4, set up the error correction model A with
Excuse me,
the error
excuse me.
correction. Yes,
Andy,
yes,
Andy, excuse me.
yes, yes,
Okay, stop here for a while, okay?
yeah.
For number 3,
Number
test
3,
two
yeah.
series are integrated, right? So what you have to
Number
do
3.
is you use the unit test to test for the residual. And you already did test the residual is stationary, right?
Yes, bro.
Okay,
Yes, bro.
the residual is stationary. So what
Yes,
does
bro.
that mean? What do you mean that if you have the stationary residuals for model A?
What I know, they have correlation between variable TBT, TB6, and TB3, bro. And then the result of this one, they can with the 1%, 5%, and 10 level and 10%. What this
In
one
other,
I know. Yeah.
so do you agree that the residual is stationary?
Yes, bro.
Yes, right?
Yes, bro.
Okay.
Yes.
So if the residuals are stationary, what do you mean by that?
Yes. It means
What
that
do you
for the
mean
Bible,
by
they have co-integration between variable, the both variable, bro.
yes? So if
Yes.
model A means that TB6 on TB3, they are
Yes, bro.
co-integrated. So model A is
Yes, bro.
co-integrating regression, right?
Yes, bro. But
Then
I didn't put this
is
one.
model A
Yeah.
spurious? So is model A spurious?
I said yes because why? Some variable time is the result is negative. It means it is
No,
negative.
no.
Yeah.
Excuse me, no.
Wrong. Yeah.
If
This
model
is
A
only my
is,
opinion, bro.
if model A is
Yes.
co-integrating regression,
Yes, bro.
then
It means
model
not
A
reuse.
is not spurious.
Spurious regression. Yes, bro. Because I see the sign negative. Okay, bro. I understand now.
As long as we
To continue, bro?
test,
Yeah.
as long test we test the model is co-integrating regression, then that regression is not spurious.
Spurious. Yeah.
This is the
Yeah,
point,
bro.
okay?
Yeah, I understand, bro. Because I see the sign negative, it means spurious regression. Okay, I understand, bro.
Whether it's positive or negative, it really doesn't matter.
Yes.
As
Yeah,
long
okay,
as
bro. I
we
understand.
test the residual of the model
For the
is
regression.
stationary, then
Yes, bro.
this model is co-integrating regression. In other words,
bro.
it is not, the result is not spurious.
Okay, bro. Understand?
Therefore, we do have long-run equilibrium. If the model is spurious, there's no long-run equilibrium at all.
Yes, bro. Yes.
You understand what I'm saying? You know, not just
I
Andy,
understand.
but also other students, right? As long as we can find the model is not spurious, then there's chance that we know the long-run equilibrium relationship exists in that model. If it is a spurious regression, there is no long-run equilibrium exist. All right?
Yes, bro.
Is that clear? Do I make myself clear?
Yes. For me, yes. But I don't know on the other.
All right,
Yes,
continue.
Understand.
Okay. Okay, number 4.
Number 4. Set up the correlation model of model A. Run the ACM of TB3 on TB3. And then this one the result. We log TB3, the coefficient 0.79, and then probability
Excuse
0.0. Yes, bro.
Okay, Andy.
Yes. Yes, yes.
Let me see this model. Okay.
Yeah.
What's your dependent variable here?
TB6, bro. Independent variable.
Are you using
And
TB6
then
and TB3, or you take the log of them? Did you take the log of them?
only that one. Yeah, this one, U1. I saw it in the U video, and then I make this one, bro.
That's my example. That is my example in the class, right?
Yeah. Yeah.
What is the model A
Yes.
in these questions? What is the dependent variable and independent variable for model A?
Independent variable for model A.
Is TB6 and TB3, right?
Yeah. Correct, bro. This one I want, yeah, this one is more confusing because with model A, this one, number 2, we include time and time too.
Show me the model A.
This one, bro. This
Your
one,
model
bro.
A. No,
This
this
one, the
is the
model A.
ECM. No, this is the ECM of model A. What is your model A? Where is your model
This one,
A?
bro. The model.
In part, I think in part 3. Show me the model A.
This one, bro. No?
Upper.
We call it model A.
Show me the model A. Oh, here, this is the model A,
one,
right?
Yeah, yeah.
This is the model A, right?
Yes, bro.
Yeah.
This
So
is the
what
model
is
A.
your dependent variable?
Independent variable TB3, time and time 2. And the dependent variable, this is TB3.
So
This is
this is the
dependent
model
variable.
Yeah,
Yes,
this
bro.
is the model A, right? And
Yes,
what
bro.
is the ECM of model A? You cannot change the dependent variables. The ECM
I
of the
see.
model A will base on the dependent variable and independent variable of TB3 here, instead of take the log of it. You see what I'm saying?
Yes. Yeah, I understand, bro. Yeah. I'm wrong, bro. I have to send, not more. Yeah, because, yeah.
That's the point. That's what I'm trying to say. Okay?
Yeah.
Okay,
Yeah, bro.
go on.
Oh.
Go on part 4. The
This is
question number 4.
already.
So here, what you have done is doing log TB6 and the log TB3. You should
Yes,
use the
bro.
original TB6 and TB3.
Yes, bro.
You see what I'm saying here?
Yeah.
Okay?
Yeah, bro.
All right.
I'm wrong. Yeah.
Okay. Then can you explain, just based on the result you have, okay? How do you
Yeah.
explain the B parts of the part of these questions? The B parts of this question.
This one, explain the meaning of coefficient of CM. If increase 1% variable, log TB3 will be increased variable log TB6 0.579. It on average 0.57% increase to variable log TB6. Yeah.
Okay. All right.
We call it short run. Yeah.
Okay. Then about part C.
And then the C, explain the process from the short run to long run. This is, I think, wrong again, bro, because I use the short run, this one. I saw this one. Must be model A, must be the answer model B, 3.
So
Based on the result, long run, I could, or
you run
yeah.
you run the log TB6 and log TB3 for your versions of model A.
Yeah, bro.
Okay.
I think
All right. Then
yeah.
then how do you explain for that?
According to the result, short run of variable TV3, 0.57925 is mean we equal with 58%. I think this is wrong because wrong model. Long run of variable TV3, 0.982546 equal 98%. This is, we call it long run variable from that one.
And what's
then
the short?
If 1% increase variable TV3.
Okay.
Bro. Yeah.
Okay.
Short run.
Then it's explain the process from short run to the long run.
Short run, I think this is wrong. Short run, I sold from that one. Or we use in log. This is wrong. We have to use that one.
Excuse me, did you explain the C part of question number 4?
Yeah, this one.
No, question number 4, C parts.
Yeah, this is for what? This is for, this is C part.
C
Explain
parts.
the process.
C parts of the question number 4. Yeah, this one.
Yeah.
How do you explain this one? The process from the short run to the long run. Lower.
This one.
Yeah, how do you?
We see this one, for the coefficient.
You didn't explain the short run. You didn't answer the C parts of question number 4, right?
Yes, bro. Yeah, we need to explain more.
The process from the short run to the long run equilibrium relationship.
Yes, bro. We have to explain about probability statistic and coefficient. I just input the coefficient, this one.
There's no process. You didn't explain it.
Yeah.
You just explained that short run is 58% and long run is 98%, but you didn't explain the process from short run to the long run.
Yes, bro. Yeah.
Am I right?
Yes, correct, bro.
Okay. Go on. Number 5. Number
Number
5.
5, Gringer causality test, TB6 and TB3. Conduct the Gringer causality test using
So-
ECM set up to equation.
Okay, so you're still using LNTB6 instead of
Yes.
TB6. Okay.
Yeah,
Okay, go
I'm using
on.
all this one. Yeah. And then because the log TB3 log 1, this is the not significant, the point 0.39, and then we join test with what test, and then we see T square 0 probability is what is the significant, the null hypothesis C equal to C2 equal C3 equal 0. And then does TB6 Gregor cause TB3? I said yes, because this on the coefficient. If increase log TB6 will be increase TB6, and TB3 will be increase TB6. This one is probability 0.02. And then we see the joint test for what test, and still have the probability is 0.0.
Okay.
Reject hypothesis. Yeah. And then see, does TB3 getting across TB3? And I answer based on the result TB3 did not significant relation to the probability higher 0.05 mean there is no greater causality between variable TB3 with variable TB6 because the result is one. And then the last
Okay.
one is the yes. Is there bilateral relation between TB6 and TB3? Yes, because on the result probability variable log TB6 is 0.00, lower than 0.05. The statistic 4.993, higher than t-table 1.977, and variable LNTB3 is 0.0226, as the 0.05, and the t-statistic 0.2 at 9, higher than table 9.97, Prof. This is my answer.
Okay. All right.
Yes, Prof.
All right. Eileen.
Hold on, Prof. And
Okay, thank you.
thank
Eileen,
you, Prof.
Good morning, Prof.
you'll be the next. Okay.
Okay.
Let's continue. I will really run out of time, so I need to take some
Break.
times. Okay. So Eileen, would you please
Yes, Prof.
do the presentation?
Can you see my screen?
All right.
So question 1, plot in a diagram TB6 and TB3. So
Okay.
the diagram shows that the variables almost have the same value, which decrease and increase at the same time. It shows a non-stationary trend.
Okay.
For number 2, with various lag, I use 0, 10, and 15 lags. Can I just jump to the summary table?
Okay.
Using these 3 lags for TB6 and TB3, we only found TB3 with lag 15 to be non-stationary. The rest are
Okay.
stationary.
Okay.
For question 3, so this is model A with
All right.
TB6 as the dependent
Okay.
variable.
Mm-hmm.
Letter B, unit root tests with various lag terms.
Mm-hmm.
So same, I used 0, 10, and 50. Residuals are stationary.
Mm-hmm.
Not sure. For letter C is model A spurious. I'm not sure if Durbin-Watson test is the right figure to look at with a value of 0.36. Therefore, model A has spurious regression.
Mm-hmm.
Does long run equilibrium exist? Yes.
But you know, I think you all have the same problem.
Same mistake.
Yeah, same mistake. You know, maybe I didn't explain it clearly. Okay, so as long as you can test the residual of the regression model is stationary, then the model is not spurious.
Yes, bro.
Okay.
Yes, bro.
Okay. Although we know that the Durbin-Watson test, you know, it's not okay. But according to the co-integration theory, tell us that if the residuals can be proof stationarity, then the model is not spurious. It's not spurious. Okay. All right.
Yes, bro.
All right. Okay. So
for number 4, we based it on the video when we watched it. So I also used log of TB6 as dependent variable.
So this is this. Okay. So this is the same problems with Andy. Okay.
Yes.
All right. Then can you explain number the C parts of number 4?
See. Here, coefficient term of negative 0.22 suggests that 22% of the discrepancy between long-term and short-term TB3 is corrected within the quarter, suggesting a slow rate of adjustment to equilibrium. The model might be simple if we included other data such as interest rate. Probably we will have a different result.
Well, maybe that. This is just the example. What I have then,
Yes.
you know, I'm just saying that maybe there's some other variables should be included in the model, but you know, this is may not be same situation of these problems. But as long as you explain the coefficient of error correction terms, which is, you know, based on your result is negative 0.22. Okay, I think you explained. This is what I really want for part C. Explain the process from the short run to the long run equilibrium relationship. Okay.
Yes.
All right.
Professor,
Although the number is not correct.
Yes, bro.
Yes.
When do we know if it's not a slow rate? What is an okay rate of adjustment?
Well, in this case, if it is significant, okay, if it is significant, maybe it's not, you know, maybe it's not, it means that the process means that the discrepancy between the short run and long run equilibrium, you know, although the long run equilibrium exists, but the short run to the long run, I mean, the between the process is working, okay? And the number here for negative 0.22 for your example, I don't know whether it's a slow or not slow. You know, according to the the big difference of your result. Okay, since you are using the different dependent variables and independent variables, right?
Yes.
So the model A, you got something like 90 something, 98 or 97%, right? But according to your ECM, since we get the short run and you are not working with the same dependent and independent variables, and looks the number is quite different. Okay, which shows in your example is something like 57% or something, right?
Yes, 57.
And this discrepancy, is a little bit, it's larger. Okay, so let me wait on until later on, if we
Okay.
have some
Yes.
more examples to show the exactly numbers, then we'll explain more. Okay.
Okay, Prof.
Okay,
Then
would you
number
please,
5.
finish the number 5.
Yes, I'm not sure about these equations. I copied it from your lecture previously, but the dependent variable I used was not the original TB6. Dependent
So
variable.
so you're using log too.
Yes, Prof.
Okay, all right, understand it.
Um,
Okay, then why don't you just stop here? Okay,
okay, Prof.
then let's get out of this session meeting. Okay, then let's come back within a minutes. Okay, because I think we need to save time for master students to do their presentation too. Okay.
Okay.
Okay, let's get out of here. Let me stop the recording and get out of here. And